Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Engineers Revolutionising Water-Sensitive Urban Design. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them, their cultures, and to elders past, present, and emerging. Before we get started, I'd like to acknowledge that today's event is being hosted with Engineers Australia's industry partner, Spell Stormwater. Spell Stormwater is Australia's leading stormwater specialist, working with councils, engineers, and contractors. They build risk-free, clean water solutions for the future. Their products and services cater to every project, and their experienced team provides advice and support in sales, delivery, installation, and maintenance. Today, we will hear from 3 speakers, followed by an audience Q&A, and I encourage you all to get involved with the session and ask our speakers your questions. I'd now like to welcome our first speaker, Andy Hornbuckle. Andy has expertise in civil engineering, biosystems, engineering and bioengineering, and has been associated with Spell since 2008. His mission is to engender and maintain a culture of ingenuity within Spell that continuously contributes to improving Australia's water and wastewater quality and compliance standards. And his journey has been of innovation and revitalisation, starting from the storm scepter and pure-receptor systems for capture and removal of hydrocarbons, tertiary cartridge technology like the Spell filter, through to ecological systems including modular and floating wetland systems. Our second speaker is Kurt Jensen. Kurt is a passionate, results-driven engineering professional with more than 12 years of experience in stormwater treatment and management. Kurt's expertise in water quality treatment and his ability to bring in other individuals from within the organisation with different expertise greatly increases a client's ability to develop a detailed concept plan for the project. Our third and final speaker is Andre Magar. Andre is the National Engineering Team Manager for Spell Stormwater, and his role mainly focuses on collaborating with consultants, councils and authorities to implement viable, effective treatment solutions across Australia. Please join me in welcoming Andy Hornbuckle, Kurt Jensen and Andre Magar.
Well, thank you very much, Amanda, for that very kind introduction. At Spell, we like to think of ourselves as the stormwater doctors. We're not general practitioners in that sense, but we are specialists. We go narrow and deep into the world of stormwater. In Australia and New Zealand, we've greatly diversified our stormwater product range. So in addition to water quality, we've added quantity, conveyance and maintenance in our mission as zero pollution ambassadors who wholeheartedly believe that clean waterways are a right, not a privilege. We manufacture, install and commission green and living assets, fiberglass, HDPE and concrete infrastructure. So I have a big reveal to make today. Our current name, Spell Stormwater, no longer actually represents who we really are and where we are really going. So the name Spell has served us very well for a long time, and it's been a terrific part of our environmental journey, stopping oily water, fuel spills and gross pollution from entering our shared streams, rivers, bays and seas. I'm very pleased to tell you that we've arrived at a collective, unanimous decision that we are going to rename as Wetland Stormwater. Atlan was the greatest king of Atlantis, and he was also known as the protector of the oceans. And that is who we are, and that is where we are going. Nothing will change the quality of our people, products, and our service, the generational assets you currently enjoy from us. Our values, team, and innovation will remain. And at Wetland Stormwater, We will continue our work as zero pollution ambassadors who wholeheartedly believe that clean waterways are a right, not a privilege. Our commitment to supporting not-for-profits, Rapid Relief Team and Stormwater Shepherds will continue. As the founder of Stormwater Shepherds, I can't resist this opportunity to promote Stormwater Shepherds' mission, which is to guide and inform communities and councils how to better maintain their stormwater infrastructure to tangibly stop plastic and gross pollution at the source. As many of you know, the stormwater network is the unfortunate and unsuspecting conveyance system or highway for plastic and gross pollution to reach our shared streams, rivers, bays and seas. At Wetland, it's our job to work upstream in the urban catchment. So same family, new name, and forever joy and water. And I'll just hand over to Kurt now to take you further into the real work that we do on the ground. Thanks, Kurt. Over to you.
Thanks, Andy. That's seriously exciting news. This picture shows where we play and what we do, really the sandpit we play in. And the reason Spell Stormwater exists, has existed and will continue to exist at Wetland is because we offer more. We offer more options for developers, more tools for engineers, more rates for councils, more cost-effective solutions for contractors. But in my mind, one of the most important things is more open and quality space for residents. This picture is an interesting one for me, as when I was a kid or a child, $1 million house was a sprawling property on an acreage. Now, $1 million house, this is just down the road from me, this image, I live in Melbourne, looks like these properties. You get in this development, a 450 square metre lot is worth $500,000. You put a 3-bedroom, 2-bathroom house off a volume builder on there, there's another $500,000. So $1 million house at the moment in Melbourne is a far cry from what is still $1 million house in my head. I guess it puts a massive importance on the quality of the open space we produce. So for developers turn to Spell when they're seeking to maximise their lot yield, when they're challenged to meet the stormwater legislation requirements, when they're frustrated with only being able to use inefficient conventional treatment and detention solutions, when they're facing pressure to resolve development application issues, and when they're excited to lift development value with open water space and quality green areas for residents. This slide here is also important to me. I'm on the left-hand side. That's a 500,000 litre OSD, or detention system underground. A zero risk for the residents of this development. This is in Geelong. On the right-hand side, you can see our open retarding basin on the southeast of Melbourne. That has a chain mesh fence around it. They're both of a similar volume of storage. One, you have a path over it and some nice green grass. The other is an open space. It's growing reeds, all sorts of rodents and reptiles around there. I have a little boy, 18 months old, and I would fear to live near an open retarding basin like this in case he got through the fence and we had a tragedy. Consulting engineers turn to Spell Stormwater when they need a treatment solution for a flat site. They need to maximise lot yield for their clients, often the developers. And they're challenged to meet the timelines for the designs they need to produce. And when they're seeking assistance with councils backed, independently validated field testing. And that's where we come in. With Spell, we have an entire range. That's from green to grey, you might say from wetlands to GPTs, oil water separation, everything in between. That's our lineup, and it's all built here in Australia. There's a few images of our fiberglass plant and our rotomolding plant. We also have multiple concrete facilities across the eastern seaboard of Australia. But taking a whole catalogue and putting it into a family or groups of products is what we like to do most. That's where we add value to what you do. We become a partner, not a supplier. We become part of your family, an indispensable asset to you. So starting at the top here, we have our primary treatment. This is where we're focusing on gross pollutants and suspended solids. It's the start of any treatment train. We have options for engineers, councils, and contractors. So there's 4 different GPTs, from your typical pit insert sack through to your well-recognised continuously deflective separating Vortceptor. We have multiple tertiary solutions. So that is our hydro system, the spell filter, the hydro channel as our mechanical, you might say, rain garden in a tank style treatment. Then we have our green assets, which are the floating wetlands and the spell basin, along with our spell bio. So there's options in the tertiary end of the world as well. We get into detention or water storage underground for harvesting. We also have options. So we have our fiberglass tanks, our chambers, our spell vault, and our megavolt. These solutions provide more flexibility for you. We also have our pipe, which many of you would know of, and our oily water separation. I guess it's about having more tools in the engineering tool belt. And then we take that range of products and we place it into, I guess, a tangible treatment train. This is really where the rubber hits the road. We, I guess, have learnt over the years that no single asset will do a whole treatment train efficiently. You get just a bioretention system and put gross pollutants and neat mud into it. It isn't very efficient. It's the same as a gross pollutant trap is not very efficient at phosphorus and nitrogen. So we believe in treatment trains. And treatment trains are how we move. It's how we design our projects. Typically, we'd start with a primary treatment solution, then have a tertiary treatment device, and then detention would fit in there as well. We can help you model these through music. I'm excited to hand you over to Andre to run through the circular economy.
Thank you, Kurt. A topic I'm super excited and passionate about. So I'm currently serving on the Stormwater New South Wales Committee, as well as previously I was serving on the UDIA Circulars Economy Committee, and I've been witnessing fields of engineering and sustainability aligning closer together. We're still not there, however, and more has to be done to ensure that the transfer from linear economies to circular economies is both successful and seamless. As the water industry is essential to any economy, the Institute of Sustainable Futures at the University of Technology in Sydney has released quality research on this topic, and they've actually identified stormwater as one of the 5 main pillars of the whole cycle, and hence developing both innovative and sustainable solutions that stop pollution reaching our precious waterways is absolutely fundamental to a thriving circular economy. So on that note, I'll hand back to Andy to present some of our innovative stormwater quality improvement devices and solutions that are revolutionizing the industry, positively contributing to future thriving circular economies.
Thank you very much, Andre. So I'm really excited to speak to you about flooding wetlands. Everybody has a pet product, and flooding wetlands is my pet product. What you see on the screen here before you looks like a couple of islands in a lake. They are actually floating wetlands in North America in the Great Lakes system. And in the foreground is a younger wetland that's getting established, and these are naturally occurring phenomena. In the background, however, with the trees on it, is also a floating wetland. It's shaped like a deep dish pie, in the base of it, and underneath it, with all that root system hanging down into the water, is a massive haven, or the Hotel Hilton for free, for the fish life and all the microbial life in the water. So when we're engaging in building man-made floating wetlands, we're actually engaging in biomimicry. And this is what I love about it, is that we're just taking nature's processes and pathways for pollutant removal, and we're mimicking them. So what is the difference between a conventional wetland and a floating wetland? So on the screen, you can see a sectional view and a plan view of a conventional wetland. You've got the inlet forebay, and then you've got the macrophyte zone where we've got the wetland plants, and you'll be getting your treatment of the water in the rhizome layer of the macrophyte zone, about 250 to maximum, say, 400 millimeters of treatment. Now, just imagine if you dug that out and it was 1.5 to 2 meters deep, open water body, and we put the floating wetland on top, right where you see those macrophytes there, and you've got the plant roots hanging down into the water column 1 to 2 meters deep. What you've just done is you've taken what was a 250 to 400 millimeter treatment zone, and you've tripled it. So we have this massive scalable system in the same footprint, and that is the power of a floating wetland. It's very simple science. There's no black magic about it. It truly works. What we're really doing is engaging in a biological warfare. So we're getting more of the good microbes to compete with the bad nutrients, the pollution in the water, and remove it. You'll see on the right-hand side of the screen here, you'll see there's the biofilm on a plant root, and then we've got the microbes that are living on it. These little guys don't have arms and legs, and they can't swim. So if they don't find surface area to attach to, they will ultimately die. In any given water column, we have 300 to 600 species of microbes generally. When you put a living surface area like plant roots into that water column, you're providing them with a habitat to live in, because the plants, and when I say living, I mean the plant is alive and it's putting a layer of oxygen into the bottom layer of biofilm. So it's a very healthy, a robust environment for the microbes to live in, and then they help to filter and treat the water from there. The plants also are taking up nutrient and helping to filter the water as well. So the thing with floating wetlands is you've got to get the plant root system to come into contact with the water column. And so you'll see in our picture on the left, that's out of a wastewater slide, where we've put a curtain off the back of the wetland that's chain weighted to the base of the lagoon, and we have slits in the top of the curtain, so we're forcing the water to come up and have contact with the root system. We work in wastewater, freshwater, and we also work in brackish water or saltwater environments. So the wetland systems are very, very versatile. We can put these systems, we prefer to put them offline because it helps with this retaining sediment. So when you've got an inline system and you get high velocity, large flows of water coming down that waterway, you can have sediment resuspended. So we've got very good designs we don't have time to go into today, whereby we can set systems up offline but still work with fluctuating water levels when you need to. But in the event that you do need an inline system, we have a product that is suitably engineered for that. The picture I'm showing you on the screen here now is a photograph of one of our brackish water or saltwater environments. This is actually a high-value canal estate in Queensland, and we had to do some research and development testing what different types of plants would work in a tidal saltwater zone. These canals are actually stormwater fed when it rains, so the plants had to work with both stormwater and then brackish water back when there's a dry period, or when the tide rises and the water comes back into the floating treatment wetland canal zone. It's a very, very successful project, and we're very pleased to be able to show you the pictures of how successful it is. The key thing for the developer in this project is that because it was a reclamation project, So they're reclaiming land, and the land is therefore of very high value. What this meant was, with the grades on the site, we were able to put the stormwater treatment system on the canal at water level, and we can fluctuate up and down with the tide. So it meant that the developer wasn't losing high value land, which could be used for open space, like you can see in one of the pictures there, and for house lots, to actual stormwater treatment. We're able to get it down and into the canal and very successfully treat the water. And for this next slide, I'll hand over to Kurt to talk to you about it, because it's his project in Victoria.
Thanks, Andy. Greatly appreciated. Some exciting projects there. And this one here is exciting for me as well. If you have a look in the sort of the center, just off center to the right, you see a terracotta roof. That's the $1 million ideal of a house that I put up on that slide before. This project's north of Melbourne. It's just over 100 hectares of catchment residential land development. And it's an interesting one. It's not an alien style project. The project was developed, lots of lots were built right to the wetland, which was the last thing to go in. It was a retarding basin and wetland, and the scheme around this area had not taken enough land. So we got a detailed design, and we were landlocked, and the allocation for the wetland was about a quarter of the footprint for a constructed wetland. And that's where the floating wetland came in, by incorporating a design that was a hybrid constructed and floating wetland system, headed up with our storm scepters. So there's 3 storm scepters replacing the sediment basins and the drying areas that are associated with it. This came in around a quarter of the footprint of a typical, or the constructed wetland required for this project. This wetland's also a hybrid retarding basin as well. So the water is retarded on top of the treatment zone, and these floating wetlands can rise and fall up to 4 metres in your 100-year or 1% AEP events. Getting the floating wetlands into a music model. This is a subject in itself that we could spend a heap of time on, but you see in the points, so point number 1, typically we would start off with looking at a catchment and work at a rule of thumb of 0.85% of that being allocated to this solution. Then we would run that in a music model to confirm or prove and refine the design. As we do this, we'll obviously be able to incorporate other measures like rainwater tanks and swales and maybe other basins in the solution, any GPTs if they're in there, into that model. As you can see, the 2 screenshots and the layout there, we split the floating wetland into 2 parts, what we call a pond, what we call a floating treatment wetland. You'll see all the inputs are mirrored and identical in both of these. That's because it's actually the same thing. We see 10 square metres of pond and 10 square metres of floating treatment wetland. What that's saying is, in a 20 square metre footprint, 50% will be open water, 50% will be floating wetlands. Now, often we'll have the question asked, what if we want a decorative lake or pond before or after this? That's absolutely fine. We can put that into the model with a separate node. I'm going to hand it back to Andy to walk through the actual product.
Yeah, thanks very much, Kurt. Probably just one quick thing I'd point out on that slide as well is that the 0.85% of the catchment is for when you're modelling for an 80, 60, 45% reduction in the music program for suspended solids, phosphorus and nitrogen. If you actually have a treatment train, it could actually be less than 0.85% of the catchment. Is that right, Kurt?
Yes, that's correct. And that's why it's our starting point. That's sort of your rule of thumb, and then you confirm, refine and downsize from there.
Yeah, very good. So the second big reveal for today is that we're releasing a new floating wetland technology onto the market. You can see the 2 triangle floats on the screen here, and then we've got a removable plant box which we can have a loose media in it. We've got over 15 years of experience with floating wetlands across hundreds of projects globally. And we've developed this product because we wanted to have a system that could have a highly engineered anchor points for inline applications and for large lake applications where you get a lot of wind chop and even waves. So we've designed this wetland to be very flexible and to be able to move with the water, not against it, like a hard, rigid pontoon. As you all know, water is a constantly moving surface, and anything that's constantly moving is destructive. So we've designed this wetland with that in mind, that we will move with the water, not against it. And a key advantage of having the inset basket with the removable media is that, as you all know, wetland plants have a life. They have a life, between 3 to 6 years, just depends on the situation and the geography. And what we've found with some wetlands is that we get invasive aquatic weeds or weed species getting into them, and it's very difficult to remove and replace. What actually does happen with these systems is that the plants completely do take over, and it becomes a big mass of organic matter, which makes it difficult to remove any noxious species that get in there. So the advantage of having the plant baskets is that if we do need to remove and replace, we can do it very, very cost effectively, very easily. The idea of the triangle and the two floats to make up a square is so that this wetland is reasonable in size. So the two triangles together is the size of an international shipping pallet, effectively. But it's small enough that you can easily handle the product, because when you're floating them onto the water, when you're working with them, putting new plants in, taking plants out, because we could actually use this product to grow food in third world countries. We could use it to grow wetlands as a byproduct of a sewage treatment plant. So there's a lot of possibilities here. We want the product to be very, very maneuverable, and easy to handle. The two allocator or joining pins that you can see there are designed with an anti-vandalism element. So there's a method and a tool involved to be able to remove those. So we're very, very excited about this product. The other thing is that we've done it as a triangle so that we can pretty well make any shape. So if you've got a wetland you need to install that needs to follow the contours of a bank or a stream or a canal, we can actually shape the wetland as such. We can also have an inset to make safe walkways, and we've got allocation pins for having handrails, which can also work to support bird netting. As many of you know, when you first install a wetland, be it a conventional or a man-made floating wetland, water hens can be quite destructive on our plants. So sometimes in an area we need to bird net. So this system has been designed with that in mind. Now, we've been engineering and working on this for a long time, and we've stress tested the product both in CFD modeling but also in the field, and we have a high degree of confidence on being able to install these systems in line. You can see the stress points there. So it's been an iterative design where we've kept on stressing the wetland and also taking into account the velocity drag caused by a fully grown system with plant roots in it. And we feel that we've arrived and we can now bring this product to the market. So we look forward to having in-depth conversations with anyone who feels that they've got a project that this product would apply to. So at Spell, we have invested heavily in research and development over a long time. I first started investing heavily in R&D in 2012 when we brought the Spell filter technology from America to the market. And the first thing the council said to me in Southeast Queensland was, look, the American data looks great, Andy, but come back when you've got some Australian data. So I went out, set out and did that. I came back, I partnered with the Queensland University of Technology. The first thing we had to do was work out what was our test protocol, because there was no test protocol in Australia. So we looked at the Auckland protocol, we looked at the German DIBT protocol, and we looked at the American Washington State Department of Ecology protocol, and we tried to pick the best of those that would work for the Australian climatic conditions and the site that we're working with to develop with QUT this protocol that we tested to. I was really excited when I got 8 rain events, qualifying rain events, went back to the council and said, look, here's my data. And they said, well, that's great, but we actually don't know how to assess this. And this is where the whole lobbying Stormwater Australia and talking to them about developing a stormwater quality improvement device evaluation protocol started to happen in the industry in 2014. So I'm pleased to talk to you about that because SQUIDEP, as we call it now, governed by Stormwater Australia, is well and truly up and running and supported by many major councils in Australia, like Gold Coast City Council and Brisbane City Council, just to name a couple. It's also supported by Sydney Water as a major water utility. So what the Stormwater Quality Improvement Device Evaluation Protocol does for councils is that it provides a uniform set of criteria which has been peer reviewed by the industry and also by a university in Melbourne. It provides measures which proprietary device companies can test any stormwater improvement device against and then see how it performs on an apples for apples basis. So the problem that councils were facing is that they needed subject matter experts in their teams with the time capacity to assess multiple manufacturers' performance claims. And before this protocol came out in Australia, all the manufacturers were testing with the best intent, but all with slightly different methods. So the beauty of SQUIDEP is that everyone has one method to work to. We're not saying it's perfect. There's a review on it coming, and we'll continue to perfect it as we move forward as an industry. But it's certainly very exciting to have a protocol like this up and running, independently governed by Stormwater Australia. The advantage for the manufacturers in working to the SQUIDEP protocol is that it's one benchmark and test point that councils can point to, so we don't have to go around to each individual council getting individual approvals for every product every time. As SQUIDEP becomes more and more adopted, it will save councils time, and it will save consulting engineers time, and it will save proprietary device companies time in working together more cohesively. So SPEL has 3 verified products at the moment on the Stormwater Australia website. We have the SPEL filter, we have the hydro channel, which is effectively filter media and gross pollutant trap in a channel drain, and we also have the SPEL basin, which is our engineered media in a rectangle basin system. We currently submitted to SQUIDEP. We have another 3 products. We have the hydro system, which is our Upflow filter media. We have our baffle box, which is a large inline gross pollutant trap. And we also have our storm sack, which is a in-pit gross pollutant trap. So that's an update for you on where we're at with that. And we have many more, well, all of our products are in various stages of testing to the SQUIDEP protocol, and we'll keep you updated on those as we move forward. So the SPEL filter is a cartridge filter for tertiary stormwater treatment. You can download the verification report and certificate off Stormwater Australia's website online. I've got a snapshot of it here on the screen. You can see the performance efficiency reductions, which are approved to be modelled in music, and this is what the councils can go by, and they talk about the music modelling method. It's very, very straightforward. We have 2 cartridge sizes in the SPEL filter. The short one requires a 550 millimeter driving head and treats at 1.5 litres per second per cartridge. And the tall one is an 850 millimeter driving head and treats at 3 litres per second. We believe in simplicity. It's a very simple and practical cartridge design. It's proven over multiple sites to be very effective for suspended solids, phosphorus and nitrogen removal. There's no false floor requirements for the vault. It can go down in any existing vault if you need to retrofit, treat a site, and we can be very flexible with the design opportunities with the system. So how the cartridge works is that the water comes in the bottom and up through the filter media, and there's a void space at the top for the water to fill, and there is an air release valve. So when the head is fully activated, it actually activates a true siphon, so that these cartridge will actually siphon down a vault, and then when the siphon is broken, it will backflush the cartridge. We can give a 5-year warranty on any site for the spell filter for performance. The only condition being that we have an active maintenance contract on the site. The reason we can give that warranty is because of the backflush feature or function of this device. It means that the filter doesn't get clogged up with the heavy sediment, and it can focus on the fine suspended solids and the nutrient removal, and then we can vac out the vaults when we go and visit the site 3 times a year or every 4 months. We're working with this product to make it a truly swap and go cartridge system, a bit like your swap and go gas bottle from the service station. So this actual HDPE cartridge will last for decades. As we all know, the problem with plastic pollution is that plastic, it doesn't go away, it doesn't decompose. So talking on a circular economy perspective, we have these cartridges that we can reuse time and time and time again. We can reuse them for decades. We just need to replace the media in them to ensure that the cation exchange for the nutrient removal is maintained. So that's it for the spell filter. And with that, I'll hand you over to my colleague Kurt again to speak to you about the Hydro system, our Upflow filter technology.
The Hydro system is a very, very versatile tertiary device. You can see in this image here, it's on a high-rise building installation. It can be used on many different types of projects, from industrial, residential, high density, medium and low density. It is a tertiary device and obviously built inside our fiberglass structure. It has cartridges in there which are scaled to suit the flow rate required for your site. It requires 250 millimeters of hydraulic head to operate. That can be configured in anything from 0 to 250 millimeters of full in your pipe work. So it makes it very flexible, especially for flat sites. How the system works: the water comes in the inlet pipe, which is labeled number 1, drops into the base of the unit, which isn't a massive sump, it's small. This is a tertiary device. It would normally be after either our storm sacks or an ecoceptor GPT style treatment. Could be a swale. The water will flow up through the cartridges, which you can see labelled as number 3. And they are just like the spell filter. The water passages up and out the top in this situation, and out the outlet pipe in number 4. So it's a wet sump as opposed to a dry sump structure. Little installation of what this looks like in the real world. This is a project on the southeastern side of Melbourne. You can see the twin 450mm diameter detention pipes running through the middle of the car park into a control pit, which will be restricting the flow. This Hydro system can treat 5 litres per second. So that's installed offline on the drawing. As you can see on the photo of the site install, sitting beside those 2 pits, plumb back in. Really simple, easy installation. Very, very small footprint as well, which makes it easier for maintenance. Obviously, every project doesn't have the luxury of that sort of install. We do quite a few projects where these are suspended from maybe the underside of level 1 or 2 in the CBDs of Australia. And that is because these buildings have Green Star requirements to hit, and more sustainability targets, which we can assist doing, potentially pick you up a point or two in the whole design and install of the hydro system, or whichever product it is. So now we change gears a wee bit and go into the spell basin. The spell basin is a modular bioretention system, and it is SquidApp verified. There's a screenshot of the SquidApp verification alongside our hydro channel verification. So the basin is verified to 86% suspended solids, 65 phosphorus and 50 nitrogen, also 99% gross pollutants. So it truly is a standalone system. This can also be modelled in music, which there's information in the verification, or you can download the nodes or have a chat with us and we can help you with that. If we jump through to what it looks like, it's a horizontal flow bioretention system. But the bit I want to quickly focus on in this image is on the left-hand side, you can see there's a chamber. In the middle, there's a media filtration zone. On the right-hand side, there's also an outlet chamber. The inlet chamber is effectively a gross pollutant trap integral to this system. And that's designed to take out all of your Coke bottles, chip packets, cigarette butts, your gross pollutants, your sediment, and also your hydrocarbons through our coalescing filter. So the water's definitely done its primary and some of its secondary treatment before it actually goes into the media layer. Major benefit of the spell basin or horizontal flow bioretention is what you can see in this image. Traditional bioretention or rain gardens are vertical flow. You can see we're really only utilising the footprint or the top surface area. We flip it on the side with a spell basin and use all of the sides through a horizontal methodology. This requires less fall or hydraulic grade to make the system activate. Also compresses the footprint, or in this instance from just under 1.5 square metres. For a normal rain garden, you're doing the same job as just under 6 square metres for a spell basin. So that means we can treat a much larger catchment in that footprint. And this is how they go together. They're prefabricated in either a fiberglass or a concrete structure by us. And we'll deliver that to site with all the ag drains and internals fitted out, and your filter media in bulky bags. So there's no risk of the contractor cutting corners or just simply making a mistake. What you design as an engineering firm and what you approve as a council will truly be in the ground and functioning to the SquidApp verification. And that's the benefit of a pre-designed, pre-constructed, prefabricated device that has been SquidApp verified. Looking at this little case study of the Port Macquarie project, we put a few spell basins in on this project. You can see there's obviously a single one on the left, a pair on the right where we're splitting the flow. One of the best things I like about this is when we went back 2 years after it went in, you can see how filthy it was on the inlet side. If we go back to the section view of the spell basin, you can see where that was. That's that left-hand chamber. With a vac truck and a high-pressure gurney to wash that out, rinse it and suck it all out, this will be back to as good as new with zero impact on the filtration media. Truly is a treatment train in a box. The hydro channel, another one of our SquidApp verified systems, and effectively useful in two applications. One, small developments like you can see, and two, with bypass catchments. So a catchment that isn't going through your main treatment train. Typically, or the going way to design bypass catchments is to over-treat your main outlet and not treat the bypass catchment. It's actually very inefficient. Costs a lot more in capital or CapEx and a lot more in OpEx to maintain as well. Hydro system solves that challenge. What it is a treatment device, a full treatment device. So it's a gross pollutant trap and a tertiary filtration system inside a 300 mil wide trench drain, trench grate or channel drain. You can see at the base it has a flow deflector to make sure we keep a void underneath it. It has a media filtration, and then on top of that, the green part is like your gross pollutant trap with a hydrocarbon baffle in there. It truly fits within a 400 mil deep channel drain, making it very simple. This next little project here is an example of a bypass catchment. So Dan Murphy's little loading dock was falling away from the main outfall by using 3 metres of hydro channel in a 6 metre channel drain. We were able to meet full compliance without doing any changes to the main treatment train. It saved a lot of drainage as well. This development in Howrah in Tasmania is a prime example of whether hydro channel comes into a league of its own. It's a 1,200 square metre parcel of land which had a house on it. Got knocked down, 3 townhouses put on it. One of the challenges with little developments like this is the cost of the stormwater treatment as a percentage in the project value. The hydro channel here, we're able to configure the roof drainage to fall into the top of it. With the storm sacks, only a $4,500 investment, which means the maintenance will be lower, and it's a win-win for everyone. We also have the hydro channel configured to fit within a pit as well, so it can be used at end of line as a tertiary device. Just another option. So having all these products, we're able to pull them into a design. Typically the recognised software is music. We can help you with that music model, or we can provide you the information to put into your music model. Once it gets through design, we'll obviously produce working drawings, which can be given to you in CAD, Revit, or whatever you need to model your building project. All our music nodes are available for download off our website, spell.com.au/music-modelling. You'll also find some helpful tips in there and differences for different councils across Australia, what's approved and required for different municipalities. Now we'll walk through the Vortceptor. We concentrate a lot on tertiary systems, on phosphorus and nitrogen, the unseen pollutants, you might say. But up front, before all this, is gross pollutant, really the start of a treatment train, is your gross pollutants and your sediment. And this is where the Vortceptor comes in. It uses a age-old technology, continuous deflective separation, and puts it into a fiberglass structure which solves quite a few challenges for contractors and creates one of the world-leading gross pollutant traps. You can see that image there is an offline system. So that's on a land development project in the western side of Melbourne. Quite a large diversion chamber on this, and that's because it's a very flat site. So we're able to modify or build the diversion chamber to the spec required for this project to make sure it was the most value-packed solution. Vortceptors come in 2 configurations. Either an inline configuration, which is pipe in, pipe out, or plug and play, or offline. There's obviously horses for courses. The inline system is very easy to install, whereas the offline system is very, very configurable, able to take many different flows and layouts on a project. Also goes up to much larger Vortceptors. The way a Vortceptor works is sort of like a top-load washing machine. The water goes in, as you can see by the red arrow on both these images, and swirls around the internal screen. Now the water is fed onto that screen tangential to the flow the inlet is. What that means when you look at the screen itself in this image is that it's fed along the face of this screen in the smoothest possible way. So looking in the direction that the water flows, it's a smooth back to it. Looking in the opposite direction back towards the flow, it's sharp. So the water, or the way the flow comes onto the screen, creates a self-cleaning screen, which the heavy sediments, light liquids, will float and sink, but it will keep itself clean, and then the water will do a U-turn and head back out. Very low K-factor, low maintenance as well. You can see in this image that red arrow explaining what it's talking about. So the water comes in, swirls through the screen using creating a low pressure zone in the middle. Your heavy pollutants will drop out, and then the water will pass through the screen back out. We also have incorporated a hydrocarbon baffle into this device. Whilst it's not an oil-water separator, it definitely helps when you're installing it on the likes of an industrial estate. These systems are engineered to go into any sort of water table. We can withstand any of your buoyancy requirements, have a specific backfill installation process, and also fully trafficable. Class B, C, D, E, F, G, whichever you require. One of the benefits with a fiberglass device also, all of our fiberglass systems, they come with a 25-year warranty on the structure and a 100-year design life. We talked about the flexibility of an offline Vortceptor. These first 4 illustrations show a bunch of different configurations that can be installed in. So from angled inlet and outlet through to multi-pipes coming in and out, and the Vortceptor can be on the left or the right side. Number 3 is one I particularly am fond of because the projects get large. Just finished a project in Melbourne where we have 12 Qmax or 12,000 litres a second coming through the diversion chambers, and we're treating 3,600 litres a second of water through the Vortceptors. And then in the 4th illustration, you can see we often will split the treated water out of the Vortceptor and send that just to the rain garden or the wetland or the tertiary device like a hydro system for polishing. The 5th illustration, you can see the inline. We have the flexibility of moving the outlet around the structure, which may work to help eliminate a junction pit and save money on the design. So that's the Vortceptor. Now, last but not least, we have our underground detention or reuse tank range. And these come in 3 different flavours. As you can see on the left-hand side, we have our megavolt system, which is a concrete modular cathedral-style tank. In the centre, we have our spell chamber, which comes in 3 sizes. It's a HDPE arch installed with stone backfill to form a void, water storage. On the right-hand side, we have our spell vault, which is individual modular tanks put together in a tank farm to form a underground void. First, we'll quickly run through is the spell vault. And as you can see in that top left image, can be configured in really any configuration that you can dream of. These can be installed in single layer tanks, so they can also be double stacked to get a higher void per footprint. And our spell filters fit inside these tanks. Regularly they're installed as really a treatment vault and detention combo. These are very, very fast to install, these structures. We did a project the other day. It was 160 cubic metres in 4 hours from start to finish. The spell vault is exceptionally fast and cost effective, up to around 250,000 litres. And from there, we would move into our megavolt range. Now, the megavolt range is concrete pillars cast into our base plate. These get laid on site. Then your top is placed on and the sides are set alongside as well. The megavolt internal heights range from 1 metre through to 3 metres, so very deep systems to suit the invert levels and grade lines on the project. These are also both the Spell Vault and the Megavolt can be designed and constructed for all traffic loadings from Class B, D, W80. We will design it to suit your project. In the centre bottom image, you can see also a weir being installed for the spell filters to go in the Megavolt, so that is also doable. Now, we spoke of this Spell Vault being cost effective up to 250,000 litres. That's where the Megavolt steps in and pushes all the way through to 5 or 10 million litres or megalitres. We had a 3,000 cubic metre, a 3 million litre tank on the Gold Coast a few months back, which was 8 days from start to finish, 8 working days install for 3 million litres. And that's trafficable backfield drive over, exceptionally fast. And then the Spell Chamber. This product here comes in 3 different sizes, from minimum of 1 metre deep installed, so it's from finished surface level to base of or to outlet of tank, through to a minimum of 2 metres from finished surface level to base of or outlet of tank. And these systems can be surrounded with a liner to make it impermeable for reuse or detention, or they can run as an infiltration structure, useful in sandy areas. We install many of these chamber tanks in installations ranging from 5 cubic metres through to 5 million litres and greater. Which brings us to the end of the detention product range. I'll hand it back to Andy to quickly run through maintenance. Thanks, Andy.
Well, thank you very much, Kurt. And wrapping up on stormwater maintenance, which is a topic that I'm very, very passionate about. It has a bit of a personal story for me because I've gone around, been in the industry a long time. I've seen a lot of plastic and gross pollution captured by the many gross pollutant traps that are in the market. And I've seen the effects of when a system is not maintained, not just treatment devices, but any stormwater infrastructure. And there is a clear lack in Australia of funding for the maintenance of our stormwater assets. And you can look on Stormwater Shepherd's YouTube channel, and I've got a detailed presentation on my views about that and the need for dedicated stormwater utilities in Australia, like they have in North America and other advanced economies like Germany in Europe. So stormwater maintenance is absolutely essential on stormwater treatment assets if we're going to keep them in optimum operating condition and stop plastic and gross pollution getting into our waterways. So at Spell, we have large maintenance teams in Brisbane, Sydney and Melbourne, smaller teams in Adelaide and Perth, and they're out there every day beating the pavement and cleaning out stormwater devices. Our technicians are certified to work in confined space and also to handle contaminated sediment and pollutants, and they're doing a terrific job. We are very, very proud of them. As you can see here at formerly Spell Wetland Stormwater, we also maintain our staff by having fun on Fridays, giving each other haircuts. But on a more serious note, I want to applaud councils like Brisbane, Sunshine Coast, Gold Coast and Blacktown City Council for putting into their development approval conditions that all private sites need to have signed maintenance contracts for their stormwater network. I really cannot thank those councils enough for what they're doing to stop plastic and gross pollution getting into our waterways by having the courage to put that in their DA conditions. What it's meant is that industry has been able to go after and procure that work and maintain those systems and stop the pollution. The next step for the industry is to move into proper funding via the stormwater utilities model that's successfully proven in North America. So you can visit the Stormwater Shepherd's YouTube channel. I've got a detailed presentation on that, and you can follow us and keep getting updates. But thank you very much for listening to our webinar today and the introduction to the Spell Stormwater products and the reveal that in July this year we're changing our name to Wetland Stormwater. Just remember that Wetland was the greatest king of Atlantis and he was the protector of the oceans, and that is who we are That is where we're going, and that is what we do every single day. Thank you very much, and I look forward to question time.
Thank you to our presenters this afternoon. Some great presentations and great content. It's now your turn to get involved. Could you please ask our speakers' questions via the chat box? And if you could put who your question is directed to. And thank you to everyone who put questions forward while they were registering for today's webinar. And we might start with you, Andy. We've had a question that's come in from Rupak, and Rupak is in Victoria, asking you, are there many failures of water-sensitive urban design we see around? It is mostly ad hoc and not fit for purpose, in my opinion. I want to know, Andy, on what steps and criteria are required to make a better choice before construction? Andy.
Yeah, thanks, Amanda. That's a very relevant and pertinent question. Very good question from Rupak. Fairly multi-dimensional. Few ways to approach it. I'd probably start by saying it comes down to education, which is not straightforward. It's difficult because every site has different constraints, and so we need skilled, educated, experienced people to be involved in the designs or the peer review of the designs to ensure that they are fit for purpose. I think you might also find that a lot of the designs that you see are failing is most likely due to a lack of maintenance. This is a very, very big subject, which we just covered off on briefly at the end of the webinar now. But even if a design is poorly done for whatever myriad of reasons, if the system is maintained, you can be pretty confident, very sure that it will actually work.
Thank you for that, Andy. And just staying with you for a moment, we've had a question coming in from Kevin, directed to both you, Andy, and Kurt. And Kevin is in the ACT. Good afternoon to you, Kevin. Andy, for floating wetlands, what are the bow wave conditions and subsequent anchorage requirements in high flow conditions? Given floating wetland systems are most effective where 100% flow transition through the root zone is achieved. Thank you for that, Kevin.
Yeah, thanks, Amanda. That's a very intelligent question from Kevin. To take the first point, bow wave or bow wave conditions, there's a big variable there. So you could be getting, like on a lake, you could be a small lake, you could be getting, 250 to 300 millimeter increments of bow wave, or like say we've got projects in the Gulf of Mexico, and you can get big storms, tornadoes going through there, and they've got 2 and 3 meter waves. So we have to look at the specific application, what the worst case scenario would be, and then we design the system to withstand that. It obviously comes with varying costs too. So if you're dealing with like 1 meter waves or half meter waves, even very consistently, it's a much bigger, more robust anchoring system, both with the anchors into the substrate or the benthic zone or to the banks, and also the attachments to the wetland itself. What, Kevin, you've touched on in the second part of your question there, really pertinent in that they're most effective where 100% flow transition through the root zone is achieved. Ideally, you want to be installing the wetlands on the inlet zones into the water bodies, or in an offline situation where it can just go up and down with the tide or flood situations, and the wetland is always offline and not heavily impacted all the time by waves or wind conditions. So we can design for these situations, but it's very just bespoke, and there is no, say, there's no one rule fits all, if that makes sense. I'll be glad of any comments that Kurt's got to make.
Yeah, it's good, Andy. All I can comment is from personal experience and application of these systems. one that comes to mind is a river in rural Victoria, where the river is used for skiing and ski boats. And we're approached by the authority who controls the river to fix an erosion problem, which is undermining some native red gums along the banks. And the floating wetlands deflect the pressure of the waves, or the energy of the waves, straight into the base of the river, and it's corrected this issue. So from that point of view, we're anchoring and have designed the anchoring to suit the ski boats. They're obviously designed to make a wave, be it a wakeboard boat or whatever sort it is. The other application that comes to mind is obviously where we put a floating wetland in a basin in a land development project, which will have a retarding function on top. It will work with detention, which will mean the wetland could rise and fall up to 4 metres we've done designs for. As Andy says, everything is designed, bespoke for the project, and we'll make it happen for you.
Thank you for that, Kurt. And Kurt, I just want to stay with you. We've had a great question come in from Mohammed. Mohammed's watching from New South Wales. Good afternoon. Asking you, Kurt, whether you agree that stagnant water bodies near urban developments can become sources of health and safety hazards and also create a financial burden due to high maintenance costs. Do you agree?
I do agree, Mohammed. One of my fears, I live in a relatively new estate. Thankfully, we don't have any open retarding basins, but I have a very small son who's just learned how to walk, and he loves running away. And my fear is that these open water bodies around new estates would hate there to be a tragedy. I think it's intelligent to put open water where it's needed and protect it from residents, pedestrians, but also use underground assets as well. From a maintenance point of view, that is a big variable. But before any open water body, there's some councils across Australia that specify there must be a gross pollutant trap installed before the water goes into a daylight situation. And I personally think that's a really good set of guidelines to work from. Keep your plastic, your gross pollutants, sediment, and some of your nutrients out of that open water body, and it all limits the amount of stagnation and pollution that can, or hazards that can happen in there. The other thing which we've done as well is put in some circulation systems using solar energy to power the pumps.
Thanks for that, Kurt. Andy, we're now going to Queensland. And a question's coming from Sean asking you, treatment devices and a register for Queensland councils. Where is this at?
That's a very good question, Sean. On our website, if you go to design assistance and music modelling, you can see on there, pick your geography, and because different councils have different requirements, and we have music nodes set up there for the councils that we have approved products with, and what their requirements are, what they'll accept for the product, but also what pollution requirements they want to remove. So that can be found on our website. Just hover over design assistance and then go down to music modeling, and you'll find the information there. If what you want is not there, be totally free to reach out to any of our staff by the phone or email, and we'll be able to give you a pretty quick, prompt answer.
Thanks for that, Andy. And we've got a question from Alberto, who's watching from Europe. Welcome to Australia, Alberto. Alberto's question, Kurt, is what's your experience in Australian cities in reusing water from a sustainable urban drainage system? Kurt.
That's an awesome question, Alberto. Typically, new houses would have rainwater tanks, so we'd be capturing the water that falls onto the roof, and that would be reused through the property for toilet flushing or irrigation on site. However, from a stormwater harvesting point of view, so on large scale or end of line scale development, Victoria does a very good job at this, especially through the drought. A lot of stormwater harvesting projects are implemented in many different ways. Other states across Australia, from my experience, don't implement it or take stormwater harvesting as seriously as some of the Victorian councils. And I think it's the future of stormwater management is to reuse it, reuse that stormwater. It's a valuable asset.
Thank you for that. And we are truly international today. We've got a question for you, Andy, from Steve. Steve, who is watching somewhere in Asia, asking, Andy, do you partner with technology providers to come up with water solutions? And are there any examples that you can share?
Yeah, that's a very good question. So yes, we do partner. And the way to approach us through that is through our website again. So if you go to our website and go to About Us, and then we have our incubator page. So that's our incubator for innovation. So if Steve applies to open communication through that medium, we can definitely have a discussion. And we have 2 of our products have kicked off and started via this process. Very good question.
Thank you. Thanks, Andy. Kurt, Angela. Good afternoon, Angela. Angela's watching from Victoria, asking you, how do we best incorporate WSUD in industrial zones? Thanks, Kurt.
Very good question, Anne, and good to hear from you. Industrial is always an interesting one, and I guess it comes down to the type of industrial development. If there is heavy pollution, like heavy metals or hydrocarbon in there, we'd always start with one of our secondary devices, like the Stormwater or the Puriceptor. Your question is, how do we best incorporate WSUD in industrial zones? Once you've done your primary and secondary treatment, you could either use a wetland, or if you're in smaller industrial areas, you can use a detention system underground and your treatment system underground. I guess real estate and footprint are the premium when you're in industrial areas. Hopefully that answers the question.
Thank you, Kurt. And just staying with you for now, we've had a question from Gracio, who's asking, can your devices such as the hydro system be installed within a flood zone? This is crucial where development close to the port can be influenced by tide flood and no other above ground space. Thank you, Kurt.
Good question. That's a good question, Gracio. Yes, they can be. The hydro systems definitely can be. Sometimes they may put a outlet flap at the discharge point to make sure no turtles or any sort of life would crawl back up the pipe and potentially block it. But the hydro system and the way it's configured definitely can take a tailwater. Anything that is pushed out of the system will have to be retreated before it'll go into the waterway.
Thank you, Kurt. Andy, we've had a question from Edris asking you, does this wetland, floating wetlands, need regular maintenance?
Yeah, that's a very good question. Thanks, Edris. Yes, they need maintenance, and it's basically the same regime as with a regular conventional surface flow wetland or bioretention basin. So you're doing the plant health checks on the wetland. We typically would go and inspect them a minimum of twice a year. I prefer to do it every 4 months, 3 times a year. With a floating wetland, the extra dimension is obviously the anchoring points. So you want to make sure that your anchoring points to the wetland are still connected and they're not, failing or wearing in any way. If they are, we design them where we can replace the wear parts, but it does take a long time for that to happen. So With the exception of the anchoring side of it, it's the same maintenance regime as a conventional wetland.
Thanks. We've had a question coming from Kong about the spell filter and spell basin, directed to you, Kurt, asking, with the spell filter and spell basin, would we need specialists to maintain this system, or can council's maintenance crew maintain them? And then goes on to ask, what is the lifespan of these products? Thank you, Kurt.
Very good question, Con. I'll break it down to a couple of questions. So the first part is, would need specialists to maintain these systems, or can council's maintenance crew maintain them? The short answer is council's maintenance crew definitely can maintain them. Spell has set up a specialist maintenance team to assist teams like council's maintenance crew and train. We're happy to train and provide all the support that's needed. It's definitely not something that ties you up with a proprietor to maintain these products. However, the thing I would add, or the point I would add there, is that our interest is to make sure that these devices are the lowest operational cost possible. And that's why our maintenance team exists. So we'd always like to have a look at how we can save operational cost on the maintenance cycle of these products. The next part is, what is the lifespan of these products? So the spell filter has a 5-year warranty on it when we're maintaining the system. And that can be, as Andy covered, that can be looked after in our swap and go style swap out program for maintenance. And the spell basin, the fiberglass will have a 25-year warranty on it, 100-year design life, or concrete will be accordingly. And the media and plants inside it would be maintained like a typical rain garden or bioretention system, with the exception that our spell basin has a gross pollutant trap on the inlet side of the bioretention system built into it. That in itself means you have pre-treatment of all the water, and it means that anything that comes in will already be screened and filtered.
Thank you. And I might just stay with you, Kurt, for a moment. We've had a question that's come in from Simon. Good afternoon to you, Simon, asking you, Kurt, are there options for different access lid types, e.g. paver, infill, access hatch for a hydro system? Thanks, Kurt.
Absolutely. The lid types that we can utilise with any of our products that are underground range from a simple pedestrian cover, be that a aluminium checker plate, or we can also utilise cast iron, like your Gaddick style covers. We can use the decorative covers with your paver infill. You might want a brass edge. We've seen some really nice tiled covers happening. And you can also use your composite covers. So it's really down to your project, and we'll work with your client, yourself, or your client's specification. Good question there, Simon.
Thank you for that. And I just want to ask a question. I mean, this afternoon we're talking about engineers revolutionising water-sensitive urban design, and a question starting with Andy. What do you see over, say, the next five years? Some of the major trends that are coming through.
I think it's very, very positive, Amanda, that Australia is taking water-sensitive urban design so seriously. I probably have a little bit of a conflict of interest in that I'm an Australian, but I do believe from what I'm seeing happening around the globe that Australia is very much a front runner and a leader in this space. And the thing that excites me is the council's interest in ensuring that the assets get maintained. That's a very, very positive movement. And I applauded certain councils during the webinar for their work on that. And if any councils want information or examples shared on how these councils are doing it, we'd be more than happy to provide it and direct you to council staff to speak to get your council going in that space. The thing is, everyone wants to build, but not enough people want to maintain. And if we maintain the assets that we've got, they will work better and they'll last a lot longer, and we'll get a far better environmental outcome. So that's really the thing that excites me. The thing that disappoints me, and we touched on this in the webinar briefly as well, is that in Australia there's not enough stormwater harvesting and reuse. Water is a very, very precious asset on planet Earth, and it's actually scarce. And in a country like Australia, where we have droughts and then floods, I think we're very poor at managing our stormwater harvesting and reuse. We could do a lot better with it. Melbourne leads the way in it, I believe, and Sydney and Brisbane could do a lot more in that space by looking to what Melbourne does.
Thanks, Andy. Thank you for that. And I might bring Andre into the discussion. And Andre, we've been working closely on this webinar. On a question on behalf of Engineers Australia, what advice would you have for our young engineers who are joining the sector around revolutionising water-sensitive urban design? And deliberately a broad question.
Thanks, Amanda. Yeah, I mean, look, sky's the limit. Everything, as I was mentioning, all engineering, all fields are getting closer together, working closer together. So yeah, just go for it. Be innovative, be daring, take risks, and yeah, and at the end, great things will happen if you take that direction. So sky's the limit. Just keep on creating and keep on designing, and the industry is welcoming all sorts of innovation and new ideas.
Thank you for that, Andre. And just to close, we've covered off a lot this afternoon. We've had a lot of presentation and a lot of content, which has been very great and rich. But starting with you, Kurt, I just wondered if you could give us the key takeouts from your presentation, and then maybe Andy, you can do the same, and Andre. Thanks, Kurt.
Thanks. I think the key takeaway from my point of view is that the future is clear. It's exciting. We can get tied up and worry about policy changes and making new laws and legislation. I think the most important thing for all of us as practitioners is to act now. They say a good plan violently executed today is better than a perfect one tomorrow. And I think the future is made starting now. As Nike says, just do it.
Thank you. Just do it. Andy.
Yeah, thanks, Amanda. I think the key takeaway I'd like to leave with our audience, other than the fact that as of July 1, we will be trading as Wetland Stormwater, the protector of the oceans, is that if you need anything, if you need to think stormwater, think Wetland, think Spell, because we have a broad range of solutions so that we can pivot and adapt to meet the site constraints, legislation requirements, release more land for development, enable you to have healthy water bodies. People love to live near water, but water has to be maintained. So that's our sandpit. That's where we play. We're very good at that, and I'd welcome any challenges, any challenging sites that the audience can throw at our team.
Thank you. Andre, have you anything to add before we close?
Yeah, just last thing I'd like to add is let's keep the conversation going on. The industry needs more work to do, and we're here trying. We want everyone part of this discussion. We really want to discuss the future, building circular economies, building new cities that are sustainable, that are innovative, that are green. But it doesn't take one company alone, on one hand alone. We need to all work together from all different industries to really focus on resilient and future-focused cities.
Thank you, Andre. So collaborate and communicate going forward. I've found today's webinar personally very inspiring, and it's good to know that this work is going on, and it very much is in line with Engineers Australia's work we're doing, culminating in this year's Climate Smart Engineering Conference to be held at the Melbourne Convention Centre in November. As always, we have run out of time, so that's all we have time for today. Please join me once again in thanking Andy Hornbuttle, Kurt Jensen and Andre McGarr for their time and input. I would also like to thank Engineers Australia's industry partner, Spell Stormwater, for now, for their support. Thank you again for joining us, and please join us for the opportunity, and please don't hesitate. Please, could you just complete the survey? It will only take a couple of minutes. It just helps us when we're looking at future topics. So on behalf of Engineers Australia and Spell Stormwater, thank you for watching, and I look forward to seeing you at a future Thought Leaders event. Thank you. Good afternoon.